Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good day. So this is um, discussion on example 4 from the notes. So the question A, okay. Then inductive AC load draws 13.4 amperes of current at a voltage of 208 volt. So we consider both current and voltage are RMS values, and the phase shift that between line voltage and line current is measured with an oscilloscope, and from the oscilloscope the value is 23 degrees. Calculate the true power and the reactive power. There are several information that you need to be carefully identify before you proceed. Okay, the first one is the current value, which is the IRMS, given 13.4, and then the voltage is 200 volt, and we need to assume that this is the load, which is inductive load, given inductive load here, and the current is flowing 13.4, and the voltage across the load is 200 volt, and the phase difference between voltage and the current is given by 23 degrees. So the angle right now is 23 degrees, but is it positive or negative? Is it positive or negative? Okay, but to determine whether it is positive or negative is actually by looking at what type of the load. So right now in the question, the load is the inductive load, meaning that the current is always lagging, meaning that the theta B minus theta I is always positive. So meaning that this must be positive value. Okay, so the true power, the average power, P is equal to V RMS multiplied with I RMS multiplied with the cos theta, which is positive 23 degrees. So this will give you the value of uh, cos positive 20 degrees is 0.92, and this will give you the answer is 2564 watt. Okay, and what about the reactive power? So the reactive power Q is VRMS multiplied with IRMS multiplied with sine positive 23 degrees. Okay, 208 multiplied with 13.4 multiplied with sine 23 degrees. This one is 0.39, and this will give you the value of 1089 var. Okay. Okay. Question B is more challenging compared to question A. So an electrician suggests to you that this lagging power factor, which is the inductive load here, may be corrected. Okay, we can correct the power factor by connecting a capacitor in parallel with the load. Okay, if the capacitor is sized just right, it will exactly offset, meaning that eliminating the reactive power, meaning that reactive power will become zero. Okay, resulting zero total reactive power. So calculate the size of the necessary capacitor in farad, assuming a line frequency of 50 hertz. Okay, so meaning that so the capacitor, okay, is connected parallel. So still the same voltage is appear here, 208 volt RMS, but right now we said that the capacitor is connected parallel with the load, with the inductive load. And the question wants you to find what is the value of the capacitance that need to be connected so that the Q will become 0. Okay, so in question A, we have already calculated our reactive power before connecting the capacitor. So this is a positive, right? This is positive because inductive load we always give positive Q. So uh, a capacitor is connected to offset to offset the reactive power generated by the inductive load, meaning that the QC, the reactive power that generated by the QC must equal to the um, generated by the inductor, which is must also equal to 1089 bar. Okay, and this QS can be referred to the slide. It can also be so the question is actually to find the C. So based on the slide, the previous slide, we can actually find the capacitor by using the formula here, V RMS square over XC. Okay, so this is negative. Okay, sorry, this is negative, so meaning that the QC also must be negative. Must be negative. So this one, so just you can just write down BRMS square over XC, and my XC can be, okay, my 2 is 208 square over 1089 var. Okay, so this will give answer of um, give the answer of 39.7 ohm, and we know that XC is actually 1 over omega C, so which is 39.7 ohm. Then from here we can calculate your capacitor. So your capacitor is 1 over 39.7 multiplied with the omega, which is 139.7 multiplied with 2 pi, and the frequency of the circuit is given 50 hertz, right? So finally the answer should be 16.6 millifarad. So this is the answer, this is the value of the capacitor that need to be connected parallel with the load. Okay, so the value of the capacitor is 16.6 millifarad. Okay, the capacitor. So that's all for example 4. So we have already finished topic 1, AC power system, part 2, the RMS value. So we will continue for topic 1, part 3. Thank you very much.